So I was checking out internet for sale for Arduino related things, and I came across this STM32 thing that looks kind of like an Arduino Nano. That it probably has a different IDE than Arduino, but you could probably make it work somehow. And in a way, it actually turned out better than that because you can just use the Arduino IDE. You just have to add some stuff to it, and then it will compile and upload to this thing. But it did throw some curves, and I'll go over that. So looking at the ad, I knew I was in for a little bit of trouble because the pin headers had not been installed on this particular STM32 board. So I knew I'd have to solder in those headers, and it got a little bit more crazy than that because I started kind of experimenting with a lot of stuff. Some of the through hole components didn't look like they had a lot of flux, and I thought maybe I'd have to resolder some of those, so I did resolder some of those. Another problem with these boards is they're known to have a resistor that's the wrong value on them that compromises the USB performance. And you really shouldn't have to be changing resistors or adding resistors because of the way resistors work. When they act in parallel, their effective value goes down. So the more of them you add, the less resistance you get. So pretty early, I found one particular guide, and there are a few different ways of working with this board, but this particular guide involves something called a STDuino, and STDuino is a sort of a framework for doing things that you do with an Arduino that was based off some other company who put out some source code that does basically the same thing for some device called a Maple device. So upon connecting this board to USB, I noticed that I wasn't getting any kind of connection. Where there was kind of a connection, but it was kind of really malformed, and it just said like it couldn't connect, and there was something there. But the idea is that you have to first flash this with some code, and then the USB will activate. And that, or at least that's the way I thought it would be, and it was in fact the way that it works. So in my experiments, it's pretty clear that the UART1, the main UART pins A9 and A10 of this board, are the ways to serial program it. There, you can also program it apparently through ST-Link, but I don't have a device that supports ST-Link. So I haven't mentioned to now the whole point of a microcontroller is that it can be kind of a breakout for a computer because it allows basically electrical signals to be controlled through USB or something, and your computer doesn't generally, or pretty much doesn't generally support anything that will have logic lines coming out of it. And these things allow for logic lines to be controlled by a computer. They also allow it to be fully disconnected and respond to sensors and do basic robotic things. These are not really fully implemented computers, but they can be used for certain tasks. So I was watching the video that I've been mostly following that involved the STDuino path, and it mentioned serial programming. I think, oh well, I've got some USB to serial converters, so I'll just hook some pins onto the serial pins and try to do it. But the trouble is that I didn't know this at the time, that this RS-232 is not the same thing as the serial that the microcontroller uses. And what the microcontroller uses is a TTL serial standard, and the TTL serial standard is not a negative voltage thing. It's between 0 and 3.3 volts, and basically it's the same thing as RS-232, but it's inverted. So it wasn't clear to me, or maybe mine is different, but there's a very specific procedure that mine requires to do serial programming, and it's a sort of situation where I nearly tear something apart trying to make it work, and nothing's really wrong with it. I'm just not using it properly. But what seems to be the case is I have to set the baud rate to 38K or 57K, and then I have to basically release the reset button on the STM32 as the Q programmer is waiting for a connection. And at that point, the two things hook together, and they keep going. There's some sort of a constant connection there being done, and you can then program whatever you want through that connection onto the chip. So something else I didn't mention was I was looking at my options, and the problem is I didn't have this what you call a TTL programmer, And I had ideas that I could use my Arduino Nano as a TTL programmer, but the problem is that these TTL devices, since they're inverted, you have a problem with this. You would usually be able to, in a serial way, put a bunch of devices on a serial bus, and basically you don't hear anything, and then one of them talks, and everybody can hear it, right? But the trouble with these TTL devices is, since they're inverted, they fill in the volt range, the data range, so that you can't just stick a bunch of them on the same bus. You somehow turn them off, right? So the Arduino Nano, that you couldn't do that because it, for whatever reason, but I noticed that on the web, people were doing basically the same thing I was doing with the Arduino Uno. And one of the ways that is definitely going to work is if you take the chip out of the socket, because then there is no other device on that bus at the same time. You can connect the RX and TX pins to some other device. Then the onboard USB interface would hook it in a TTL way to whatever thing you hooked it into. And in fact, it can be used as a TTL converter in that manner. So in my neighborhood, there was somebody selling an Arduino Uno for like $20 with the whole kit. And that was, originally I was thinking, that's a great deal, but I don't really need it. But in this case, it could be used as a TTL converter. So very quickly, I scooped that the next day. I think it was like some student that was like trying to unload some stuff. And it turns out that I kept taking the chip out because I thought maybe the chip needed to be taken out, and I didn't know about this procedure. It wasn't really laid out to me. I was expecting that there was no procedure to do this flash. So it turned out I caused a little bit of physical damage taking the chip out. And it turned out you really don't have to take the chip out, because it does work to short the ground and reset together, and then the chip will kind of disappear. And it's as if you took the chip out, and that's really would have helped. But I didn't know about this procedure to how the timing was going to work for the programmer. So, like, it's dangerous when I'm trying things when I don't really know what the problem is. And I had replaced R10. I don't really know if R10 needed to be replaced with a lower value to make USB reliable. But when it failed the program, I was sort of searching for various problems, and I was trying to clean off the board to get rid of any problems. And it since that solder connection to that resistor wasn't great, it severed it, and the USB went offline. And originally, I didn't know if I had damaged the board or that particular resistor was wrong. So I started working on that resistor as a possible logical problem. So I was pretty sure that it was done for, because I messed up one of the pads. I lifted one of the pads on the resistor. I knew it was pretty much over. So at that point, I was pretty desperate. I was trying to clean up solder, and I even unlifted another resistor nearby that I had to put back later. And I looked at the schematic once, and I noticed that the particular situation, I could probably bypass that resistor the way it was laid out. So here we have the affected region. And what happens is, luckily in this case, R10 is coming off of a main line, and it crosses the resistor and then goes through the board. So you can actually, in this case, replace it by connecting two pins that are on the outside of the board together with a resistor. So following the guide, that video is pretty comprehensive, except for two main problems that maybe wasn't experienced by them, is the specific timing of my serial programming. The fact that I needed a TTL programmer, although it was they'd used their TTL programmer in that video. So I was also testing in Linux, and Linux did not inherently work, but using that exact procedure as in the video I mentioned, Windows did work. But what happened was I went back to Linux and I copied certain files out of that newer third-party DFU driver, and then Linux started to work as well. So now I have Windows and Linux working, and the particular bootloader mentioned in that video is appropriate for this particular manner of doing this, and it's all working pretty much the same way as if it were a literal Arduino, but the STM chip has better performance specs.